Hello everyone, welcome back to the channel. We are doing Leetcode 2537, count the number of good subarrays, which also happens to be the problem of the day for today. Given an integer array nums and an integer k, so you're given two things, return the number of good subarrays. What constitutes a good subarray? A subarray is good if there are at least k pairs of indices I, j, k pairs of indices such that I is less than j, and the array of I is equals to array of j. So the number at index at index I is equal to the number at index j. Subarray is a contiguous, very important, contiguous, non-empty sequence of elements within an array. Okay. So before actually looking at example number 1, let's first have a look at example number 2. 3143224. So it says you have four different good subarrays. The first good subarray is 314322. Why? Because it has two threes and two twos. Now 314322 including 4. Now why is it a good subarray? Because again it has two threes and uh, two twos. But the good thing is it also has two fours, isn't it? It also has two fours. So it basically, they're not saying that a good subarray is something which has like exactly k pairs of indices, at least k pairs of indices. Okay, now even if now you remove the 3, still you have got two pairs. You see, you have 4 4 and 2 2, and even if you remove this 1, you still have 4 4 and 2 2. So overall you have 4 pairs. Now if you are someone who has been into comparative programming and data structures and algorithms for a month or so, after seeing this example, you have no doubt that this is a classical, this is the most, you can say, representative question of how sliding window approach works. Okay, so I have already copy and pasted both the examples over here. Let's have a look at let's have a look at why I'm saying that this is the classic sliding window technique. 3143224. And what you will realize is that this is not just sliding window, but you will have to use two other techniques as well over here, right? So let's say I take two pointers I and j. This would be the starting. So I is the starting of my window, and similarly j is the end of my window. Okay, so from I to j is basically what my window is. Right now it just constitutes of 3, so I have 3. Then I increment my window. I experience this one, okay, then this, okay, then this. Now I have one pair. But then how would I know that at this point I have one pair? I will obviously have to track what I will have to track their frequencies, right? So how can I do that? A very good, a very efficient data structure that lets me do it is a map. Okay, so when my nums of j is 3, what I'll do is I'm going to keep track of all the numbers which I access through the index j. Okay, so the 3's frequencies become 1, then 1's frequency is going to become 1, then 4's frequency is going to become 1, okay, then 3's frequency is going to become 2. Why? Because a map basically stores unique key value pairs. That is something which you already know. Then I have 2, so 2's frequency is going to become 1, and then at this point 2's frequency is going to become 2. The thing is, at this point I have two good pairs, isn't it? Two pairs such that I is less than j and nums of I is equal nums of j. But then how would I know? So one way of knowing is that I iterate through the map after each operation. You know, when my j was at this point, and when this was the state of the map, I iterate through the map and I keep track of how many numbers have their frequency set as 2. That is one approach which I can use, right? And then when again I iterate through the map, there are no two pairs, so it doesn't really matter. But then when I do this, when 2's frequency becomes 2, then when I iterate, I get to know that I at this point I have two pairs. So now what I can do is, this window which is represented by my I to j, this it can be set as a you can say a good subarray, isn't it? 314322, that's the first good subarray. So one way of knowing what a good subarray is by iterating through the map, but then do we have something better? Can I further optimize this? Yes, I can. How? By using a set. And why I'm using a set, that I'll also tell you. See, whenever any number reaches the frequency of 2, I'm just going to do nothing, but I'm going to insert it into the set. Okay, I'm going to insert it into the set. Then as soon as 2 reaches the frequency of 2, I'm going to insert this in the set as well. Now I don't have to do the O of n operation of iterating through the map. I just have to see what the size of the set is. So if the size of the set is 2 or more, then I know basically that, not 2 or more, basically k or more, right? In this scenario, k was 10. Right now I have k as 2, so I need 2 pairs. In this one I need to have 10 pairs, and we are going to go over this particular test case as well, right? So if in general, if it's k or more, then what I'll do is I'll keep a count of how many good subarrays I have, right? Right now it becomes 1. Then uh thing is, 4 comes over here, so j comes over here, then I'll have to increment the frequency of this as well. So this is going to get inserted into my set as well. Why? Because the frequency of 4 has reached what? It has reached k. Zabardast. So now again, after this, my j is going to get out of bounds, right? After I increment j, my j goes out of bounds. But then if still right now I had 2. I have I have gone through this particular good subarray, I have gone through this particular subarray, but what about these? Right. Up and until now, I was only expanding my window. Okay, I was only expanding my window. Now what I'm going to do is I'm going to shrink it. I'm going to shrink my window. Okay, and how I'm going to do that is I increment the starting pointer. When I do that, you see this 3 basically exited my window. So what I'm going to do is, my eye was over here, right? My eye was initially at 0. So when it was at 0, I'm going to go inside the map and I'm going to decrease its frequency by 1. After I do that, then I'm going to increment my eye. Okay, makes sense. Perfect. Now 3 has become 1. You see, its frequency has become less than k. So it needs to go out of my set. The good thing is that I'll just do set.erase, and this, I think this does not take O of n. I think this operation takes O of log n. So a question can be, why did I not use a vector? I could have used a vector as well. But then if for finding for finding any number inside a vector, it takes at worst case O of n. But in a set, I'm not really sure, but I think erasing something or finding something takes O of log n operation. So that again is an optimization, isn't it? Zabardast. Perfect. That is why I took a set basically and not a vector. Okay. So, okay. Now, even after 3 has exited my set, because its frequency has become less than k, still my set has a size of equal to k or not, or k or more. So what I'll do is I'll increment my count again 3. So this particular window from I to j covers this particular test case. Then again I shrink it. I come here, 1 has exited my window, so 1's frequency is going to become 0, right? Nothing really happens to my set. My set still has a size of 2, which is equal to or greater than k. I'm going to increment my count. So that means, since my set still has a size of equal to or more than k, this constitutes as a good subarray, right? My count is going to become 4, and then thing is, when I increment my I, it was here. When I now increment it, and then when I go and when I decrement the frequency of 4 from my map, I will have to erase it from my set. My set dot size has become 1. My j is already out of bounds. So at this point, I need to stop my process because I do not have any more good subarrays. Make sense? I do not have any more good subarrays. So at this point, what I want you to do is, I actually want you to pause the video and try this example number 1 on your own. We're going to do this, but what I want you to do is, I want you to also try the problem on your own. Okay, right? Okay, so 1 1 1 and k is equals to 10. Let's do it with a different color. So I have 1 1 1 1 1, or let's just say 1 1 1 1 1. This is my array, and the k is equals to 10. Okay, perfect. My I is at here, starting point, my j is at here. I'm going to take a map, right? Once frequency is going to become 1, then once frequency is going to become 2, and ultimately, I keep incrementing until it goes out of bound, and at that point, once frequency is going to be 5, isn't it? And I'm going to put one inside my set. Okay, the bad thing over here is that this particular approach, I just realized this particular approach, taking the elements and putting them into the set, is not going to work over here, because inside my set I only have one element, right? Now the thing is, if we take a look back at the problem statement, array of I equal array of j, and I is less than j, and there are at least k pairs of indices. So we are not concerned with, if I do set dot size, that would mean that set dot size is basically going to give you the different numbers, right? Distinct pairs. And in this particular example, I had distinct pairs. So I had 3 and 3, I had 2 and 2, and I had 4 and 4. But then in this, all of them are equal. So this approach is not going to work in this scenario, and that is very clear. So I'll have to modify my approach a bit, right? I'll have to modify it. How will I do it? Now, since this approach doesn't work, let's see how will I do it. I am still nonetheless going to take a map. Once frequency is going to become 1, then once frequency is going to become 2, okay. Then once frequency is going to become 3. What does this mean? This means a very important thing. When once frequency became 2, that led you to know, when your j was at this point, that led you to know that you have uh, one one pair, where I is less than j, and nums of I is equal nums of j, right? Nums of I equal nums of j. But then now you have 3 pairs. Once frequency has become 3, what does that mean? It means that this is one pair, you already have that, you already have captured that. But then there are 2 pairs which you still haven't captured. Let me circle them with a different colors. This one and this one, and this one and this one. So 2 pairs, isn't it? Now you have 2 more pairs of what? Now you have 2 more pairs of, you can say, where I is less than j and nums of I equal nums of j. Then again, what's going to happen is you're going to increment your j once frequency is going to become 4. Now how many pairs? One thing which I'm going to say is maybe 3 pairs, because this was 1, this was 2, so maybe it would be 3. Let's see, I'm not really sure. So I have covered this pair, I have covered this pair, and I have covered the this one, this pair as well. But then since this number has now been introduced to me, what are the pairs which I'm going to get, which I already haven't covered? 1, 2, 3. You see, 1, 2, and 3. And then, do I have any more? I do not. So 3 pairs are going to be added. Okay. Then I increment my j. The frequency of 1 becomes 5. How many pairs am I going to add? I think 4. I'm not really sure. I think 4. Why? Because you see, this one can pair with this one as well, this one as well, this one as well, and this one as well. Why? Because the I is less than j in all these scenarios, right? And nums of I equal nums of j. So if you add, the natural sum of first 4 numbers, 1, 2, 3, 4 is 10. That's why your answer was 10. Your answer was 1, because k was equals to 10. And if you take this whole nums, array as one subarray, then only you're going to get the answer. What I want you what I want you to think about is this thing. What if I had just a one more, just one more number? Then how many pairs would I have had? I would have had five pairs more. So 15 in total, right? In that scenario, what would have been the answer? Think about it. And let's just say you had one more one. So 21 pairs. In that scenario, K was 10. Okay, K was 10. In that scenario, what would have been the answer? Just think about it. Okay, I'm not going to give you the answer. Just think about it, and then you can very easily go and check the answer from Leetcode's environment. Right? Perfect. So, uh, if I now apply the approach over here, I know that I do not need a set. I do not need a set, but what I do need is this sort of an approach, right? So, what's going to happen? I'm still going to keep track of every number. Still going to keep track of every number. So I have, I have 3 how many times? I have 3 two times. I have 1 one time. I have 4 two times. And then I have 2 two times. Okay, what does this mean? This means now you see, I'm not going to, I cannot pre-compute this map and then calculate the answer, because as you saw, I was expanding my window and counting the pairs at the same time, right? So there is, I think it would be better if you don't pre-compute the map, if you do it on the go. So we are going to do it one more time. The 3 frequency is 1, then I have 1. Okay, okay. I have 4 over here, 4. Then I have 3 again. So 3's frequency has become 2. Now, uh, what did the problem statement said? It said an array, a subarray is good if there are at least k pairs of indices, two pairs of indices I comma j such that I is less than j and array of I is equal n. Right now I just have one pair, 3 and 3. Right, I do not have two pairs, so that is something which I'll need to keep in mind. I just have one pair. Okay, what I'm doing is I'm counting the pairs. Over here what I did was I was counting the pairs, so I'm going to do something similar over here, and I'll see if it leads me, if it leads me somewhere, right? Okay, so then I have 2 frequency 1, and then again I have 2 frequency 2. Now I have 2 pairs, isn't it? I have 2 pairs. But still, in this scenario I think I will no, I'm counting pairs, right? So when when this became 2, I must have said that the pairs which I must have incremented the pairs by what? 2 minus 1, because you see what happened is, when I had frequency 5, when I had frequency 5, what did I increment the count of pairs by? I incremented the count of pairs by 4, which is actually 5 minus 1. So just number of pairs which you're going to increment is actually equals to frequency minus 1. Right, perfect, zabardast. So when you have 2, you're just going to say that you have 2 minus 1 yani 1 pair. You encounter 2, you're going to say you have another 2 minus 1 yani 1 plus 1. At this point you have 2 good pairs. Since you have 2 good pairs, this counts as a good subarray, isn't it? Perfect, perfect, perfect. Then when you encounter this 4, this becomes 2. Okay, one thing, one thing. So at this point you see, um I what I want to do is, I don't want to shrink my window. I don't want to shrink my window. Uh thing is, the thing is, देखो, if the 2 wasn't present over here, let's say for a moment 2 isn't present over here, this 2 does not exist. Okay, so 2's frequency is 1, we're just assuming it for a moment. In that scenario, 2's frequency would have been 1, and this 4 would have been the second good pair, and my k was equals to 2. So I call a subarray good when I actually get two pairs, right? When I reached this 4, I got two pairs and I said 1 plus 1. Okay, this one wasn't already there. I said 1 plus 1, I have two pairs. Perfect. I at this point I have two good pairs. But then thing is, I already had two good pairs before. I already had them. So even if this was 10, even if this was number 10 and I expanded my window, I would have had to add 1 over here, right? Because when I expand my window, I reach this point, 3, 3 and 2, 2 are still there. And although this 10 is not giving me any value, but it's giving me, it's not giving me any value because of itself, because of what it is. It's not. But then it's giving me value because I already have, uh, two pairs. I already have them. So I expand my window. I already have two good pairs. So I do 1 plus 1, right? The thing is, this number was actually 4, right? So I don't need to add 1, I need to add 2. Why? Because there were already this 3 and 2 pair, right? If this was 10, this would have added 1 to the number of my good pairs. But then this was 4. And 4, the good thing is that I already have 1 4 over here as well. So you know what happens? Frequency becomes 2. And then this 4 pair is going to add 1 to my, this 4 pair is going to add 1 to my number of pairs. And because I already had two pairs, 3 3 and 2 2, this is again Mazid going to add one pair to the number of my pairs. So 1 plus 1 plus 2, that's how you get 4. Okay, this is one thing, which means that you need to have a set as well, or a vector, doesn't really matter. You just want to calculate the size. You already had 3 and you already had 2. When 4 was introduced, the before 4 was introduced, actually the size of this was already 2. Makes sense? So the thing is, you're going to do 2 minus 1, it becomes 1. Okay, you're going to add 1 to the pairs. Why? Because you already had two good pairs. You see, you already had two good pairs. And then since 2's frequency becomes 4, you're going to add what? 2 minus 1 to the good number of pairs. So 4's, two 4's, you have two 4's, right? So this is how I think our solution is going to build itself up. Let's now try to code it up. Okay, we'll see what the requirements are, and we'll code all of those requirements one by one. Now, what do I need to do? Acha, the number of good subarrays can be long, because I need to return long, right? So I'm going to take the answer as, initialize it as 0. Okay, perfect. Then what I need to have is a map, and let's take int comma long over here, mp. Okay, then what I need is a set of integers, st. Then what else? I need to start from I. I actually don't need two pointers. I just need a single pointer, right? So just I, for int I equals 0, I is less than n is num start size, basically I plus plus, right? Okay, I do that, and then so when I was at 3, what I'm going to do is I'm going to say mp of I plus plus, and I increment its frequency. 3's frequency becomes 1, right? Then 1's frequency becomes 1, then 4's frequency becomes 1, then 3's frequency becomes 2. As soon as 3's frequency becomes 2, do I need to do something? I need to count the number of pairs. I need to count the number of pairs. So I can do something like this: int count pairs. Count pairs equals 0, and then I'm going to say over here that pairs. Yeah, I'm counting pairs. If mp of I, if it's when I had the frequency 3, I added 2. When I had the frequency 4, I added 3. When I had frequency 5, I added 4. If mp of I is greater than or equal to 2, what do I need to add to count pairs? I need to add count pairs. plus equal MP of I minus 1. Very important. MP of I minus 1. And what's the logic? You know the logic, right? The first test case was actually very meaningful and very insightful for us. Through that, we actually calculated how we are going to calculate the number of count pairs. Okay, perfect. Then I have this 2. So 2's frequency becomes 1. Then 2's frequency becomes 2. Count pairs actually become equal to 2. When that happens, when count pair becomes equal to 2, if count pairs are greater than equal to what? K. Then what you need to do? You need to increment your answer. Acha. Do I want how much by? How much do I need to increment by answer? Right now I'm just going to do answer plus plus. Why? Because the current scenario wants me to. I have 2 pairs. I just need to increment my answer. Okay. But then what happens? Then you come across another 4 and its frequency becomes 2 as well. Now, one thing is, acha, by the way, wait. Mm, where is 1 plus 1 plus 2? It actually wants you to. Um, acha, what if the 4 wasn't here? It was just 314 and 322. You know what? In that scenario, your answer, if it was 314 322 and this 4 wasn't there, in that scenario the number of good subarrays would have been 2 and not 4, right? So what I think I need to do is I need to count the number of good pairs, and I just want the overall final answer is going to be, I just want to count all the good pairs and I'm just going to divide them at the end by k. Okay, so maybe I'm not really sure. Return count pairs divided by k. If I submit this, if I run this on the example test cases, it gives me 0. It gives me 0. Why? Why? Okay, so if after each and every iteration I want to see how many count pairs do I have, then what happens? I get 0, 0, 0, and it's not actually my count pairs is not. Why? If MP of I is greater than equals to 2, why would that? Um, uh, why does it not? So actually, let me see what MP of I is turning out to be. 1, 1, 1, 1. Why MP of I plus plus? Why does it? Uh, Number of I. Sorry. Yeah. Rookie mistake. This is going to be nums of I. So because I actually was incrementing the frequency of the indexes rather than the numbers. Okay, sorry. Okay, let's wait. One, two, three, four, five. I get the answer as 0. 1, 1, 1, 2, 1, 2, 2. I get the answer as 0. Count pairs divided by k, right? Sure. Count pairs. At this point, I'm getting the right frequency. Yeah, 2. Yeah. So if I do the count pairs, then I'm getting 0 1 1 1 1. Why is that so? It wouldn't shouldn't have been number 5 plus number 5 needs to be number 5, needs to be number 5, right? A very rookie mistake. This happens, doesn't, it's okay, it happens. So I'm getting the right answer for this, but then why would the count, acha, I actually missed one thing, right? It says the count pairs are 3, whereas it they should have been 4, right? Why did I make the set? So I'm not actually, if mp of nums of I is greater than equals to 2, then what else do I need to do? I also need to, if there could be one thing that all the numbers are equal, so the map is going to handle that case. mp of nums of I minus 1. If you have 5 equal numbers, you need to add 4 pairs. The map is going to handle that case. But then there can be a scenario where you have different pairs. So you need a set for that, right? You need to do ft.insert, ft.insert what? ft.insert the nums of I. st.insert nums of I. You need to do this. And acha, before insertion, you need to check if there were already k things present. Before insertion, you need to check if there were already k things present. If ft.size, if it's already equal or greater than equal, if it's greater than equals to k, then what you need to do, again, depends, right? uh, I had two pairs. That is why I added an extra one. If I had three pairs, then what? I would have had to add two. So what I'm going to do is I'm going to say count pairs plus equal st.size minus 1. I think, yeah. And then afterwards you insert it into the set. Let's see. 4, it became 4 just like I wanted. Output 2, expected 4. That is wrong. I need to return, I don't need to return 4 divide. But then why would count pairs be equal to 4? Count pairs would be equal to 4. Yes, and the overall answer that I need to return is also equal to 4. Uh, hmm, wait, I'm actually not taking into consideration this one at all. That is something which I just realized right at this point. This one actually adds value as well, right? This one adds value as well. So I will have to modify my approach all over. So since this video is going too long, I'm going to sort of upload it as a failed attempt, and then I'll change this, I'll figure out the correct solution, and I'll make a separate video for that. I hope you liked the thought process and you got some value out of this video, and I'll see you in the next one.